Okay, so I have about a minute to try to explain things here before this detonates. Let's start at the wall. This is kind of looking at the light bulb and inrush currents and the phase at which you switch in that light bulb and how that affects the inrush current. So I have an oscilloscope hooked up. Here's actually the schematic. I should start there. Solid state relay controlled by a microcontroller with a battery. This is a 1 amp relay. So basically here we have that relay. There's actually a switch. Manually I can switch it in parallel, but I leave that off. Got about 15 seconds left before this will go. And this microcontroller CC2652RB by Texas Instruments. And in a moment here we should see this light bulb flash. Weirdly looks like two flashes there. But here's what was captured. So this has no extra delay, but because of the on time and the off time, you end up capturing actually basically a peak is where it switched on, and it switched off slightly after the zero crossing point. Okay, let me trigger this again because I have it set up for another pulse with better timing, which probably has about 30 seconds left before that goes. So here we were on this, talking about this, basically a battery connected to this MCU. It's all pretty crudely hooked up, as you can see. Driving that relay, I have this 330 ohm resistor there, which I could remove to get a little more pumping action, but I don't need to at this point. I can just manually offset these delays. And this should go off in about maybe 10 more seconds here. We'll get now better timing, but again, it's so fast. I have it basically doing 4 cycles. So this is what I got there when I added in a little delay. You can see that I got perfect zero crossing here. So what's left to be done? Actually, this I should say is an 8.5 watt light bulb, LED light bulb. It always showing 0 watts on here because it's only 4 cycles, so you don't actually see anything in the power meter. All right, what I'm tempted to do at this point is to, like I wrote in here, to add some sense resistance and measure these inrush currents. So let me hook that up and come right back. Okay, so there you can see the little nichrome wire I've added, 2.6 ohms, so just divide by 2.6. For channel 2, you can see the ground there is connected across that. And since that ground's connected, I actually don't need this other oscilloscope ground connected. Got 2 channels here set up. And while I have a chance, let me also show this case a little better. It has a relay, it has a manual switch, it has that 1.5 mega ohms. The case is actually tied to the green ground coming from that white power lead. Here I've got the microcontroller that's Bluetooth operated, and that's difficult for me because I'm trying to take this video with the same phone that I'm also trying to control it with the Bluetooth, so that's why I sent it this long-winded script. Okay, well there we had that. Let me turn off the light here. Saw that flash, so here's what the trigger looked like. You can see a basic moderate inrush current. It's really no worse for the first peak versus the second positive peak. Second positive peak actually looks worse. Okay, so turning this on single mode so we can get the next pulse. In the meantime, let me also show the schematic for this light bulb. I think there's also a 20 ohm fuse that I don't have drawn here. But basically that BP device there seems to be doing a good job of inrush current limitation. Okay, the power factor on this is 0.8, and it's drawing about 8.5 watts. You know, if you look at this, you wouldn't think the power factor is that good, but I guess that's what the calculation is. It's still a good power factor. So now, we're going to get a zero crossing waveform. So let me zoom out so we can capture this better. Okay. There you can see the zero crossing, and actually here the inrush current is worse on that first negative going peak. But it's still not bad. We're talking at most 1 volt divided by 2 ohms. 2.6 ohms actually, so 400 milliamps. So steady state, this is drawing an average of about 80 milliamps, so not too surprising. Everything is kind of checking out. So here we go. This is the light bulb inrush current test for a low power light bulb, just kind of to see how things get going here on my first experiments with this. I'm also going to play around with modulating this relay on time and see if I can dim this bulb a little. Okay, well I thought I should actually show some other options, some dimming options. Here's a kind of obvious thing that a triac would probably be better suited as. 2 half cycles on, 1 half cycle off. 2 half cycles on, 1 half cycle off. And that, instead of the 8.7 watts normally, it draws about half of that power. So it's going to settle around 4.4 watts. And so here's that brightness. And actually you're going to see it in a moment here switch on to full brightness. There we go. So that's full brightness like this. Again, that's the voltage and current waveforms through a 2.6 ohm resistor for the green channel 2 waveform. So anyway, this is now building up to the full power, which is about 8.5 watts. Okay, I got one more brightness level, one more dimming option to show you. Okay, and here's another type of dimming, which is a little more violent on the relay, but we're basically cutting out the peak part of the waveform. And this gives us about, it's going to ramp up to about 3 watts. So, of course, the auto exposure on this camera doesn't help to understand the brightness levels. But I will try to do a slow-mo video also and attach that at the end here. And in a moment it should go to normal brightness where the waveform fills out. Let's see what we got there, 3 watts. Oh, there's the full brightness. And that's the full brightness, which should come up to about 8.5 watts. Oh, it's actually 9 watts. I don't know, I don't trust that meter so much, but it says 9. And that's what a full waveform looks like. And okay, that's the setup. And like I said, I'm going to just put on some slow-mo videos to show the flicker and the brightness of these different dim settings.